Good noon to everyone. Today discuss about chemical engineering plant economics માં ડિસ્કસ કરીશું આપણે આજે સિલેક્શન ઓફ પ્રોસેસ ઇક્વિપમેન્ટ એન્ડ પાઇપિંગ ડિઝાઇન વડે એમાં આપણે મટીરિયલ ઓફ સિલેક્શન ઓફ મટીરિયલ જોઈશું ફર્સ્ટ ઓફ ઓલ એન્ડ સમ ફેબ્રિકેશન સિલેક્શન. Now start the selection of process in the any material. Okay. Now a schematic as a chemical process plant and turn to higher temperature ના wages પર જોઈશું આપણે at flow rate to the best yield and through outputs. Selection of construction material take an added importance because this serves condition intensify some corrosive actions. Okay. સિમ્પલ જે મટીરિયલ અને ફેબ્રિકેશનનું સિલેક્શન છે એના બેઝિસ પર આપણે જોવાનું છે કે સિલેક્શન ઓફ પ્રોસેસ ઇક્વિપમેન્ટ કઈ રીતે થશે, સ્ટાન્ડર્ડ વર્સિસ સિલેક્શન ઇક્વિપમેન્ટ કઈ રીતે થશે, સ્પેસિફિકેશન શીટ ફોર ઇક્વિપમેન્ટ કઈ રીતે થશે, સિલેક્શન ઓફ ઇક્વિપમેન્ટ સાઇઝ રિડક્શન, ઓકે, ઇક્વિપમેન્ટ હીટ ટ્રાન્સફર ઇક્વિપમેન્ટ, હાઉ ટુ હેન્ડલ ઇટ. ઓકે, સિમ્પલી ધીસ ઇઝ અ mass transfer equipment, material handling equipment, pumping, pipe and pipe strength, wall thickness, piping design problems, piping layout, some rule ferrous and non-ferrous pipe જોવાનો છે, non-metallic piping and tubing, types of insulation, factor governing selection of insulations. Okay, this all part in this point. Okay, simply as a chemical process plant turn to the higher temperature and flow rate to the boss yield and through output selection of construction material take on added importance because this serves conditions intensify the corrosive actions. Ferrous and broad range of the material is now available for corrosive and service. However, this apparent abundance of material also complicates apply the task of selecting and best material because in many cases a number of alloys and plastic will have the sufficient corrosion resistance for a particular applications. Final choice cannot be based simply on selecting a suitable material from a corrosion table but must be based on a simply material economic analysis of compacting materials. Simply some purposes of this chapter is to provide the design engineering with a working knowledge of the sum of the major forms and types of materials available, why they offered and how they are specified. With this background, the engineer can consultant a material specialist during the early stages of the design to establish the material that best meet the process conditions. Okay, now this is the factors contributing to the corrosion. Corrosion is a complex phenomena that may be involve one or more forms. The corrosion of metals specifically applies to chemical or electrochemical attack. The corrosion is often confined to the metal surfaces, but sometimes it may be occurs along grain boundaries or other metals weaknesses because of a differences in a resistance to attack or local electrolytic actions, and the deterioration of plastics and other non-metallic materials is essentially some physically rather than the electrochemical and result swelling, crazing, cracking, softening materials, decomposition, non metallic materials can either deteriorate rapidly when exposed to a particular environment to be practically unaffected. Okay, simply જે જોયું આપણે કે simply starting ના basis પર this point. The purpose of this chapter, which is to provide a design engineer with a wrong knowledge of some of the major forms and the types of the material available, what they offered, how they specified. With this background, the engineer can be consult a material specialist during the early stages of the design to establishment of the material based with the process condition also. Okay, near this point. Simply, what is a factor of materials for contributing the corrosion part? The corrosion is a complex phenomena that may be involve one or more forms. The corrosion to metals specifically applies to chemical or electrochemical attack. The corrosion is often confined to the metal surfaces, but sometimes it may be occurs along grain boundaries or other metals. Some weakness is because of a difference in a resistance to the attack or local electrolytic action, and the deteriorations of plastics and other non-metallic material is essentially some physical chemical rather than electromechanical and electrochemical. Result is a swelling, crazing, cracking, softening or a decomposition part. Non-metallic material can either deteriorate rapidly when exposed to a particular environment or a particularly unaffected part. Okay, now this continuous section. A table जो एक वक्त this is a series of the metal and alloys. Okay, one by one. Magnesium alloy, zinc, one by one. Okay, this is a most ofly metals and alloys part table in this format. Okay, there are both localized and structural aspect of the corrosion associated with metals and corrosive actions on a localized level occurs at areas such as survives. Okay, and there are some boundaries. The oxygen deficient cells or stress activated surfaces, corrosive actions can also be initiated by galvanic action in pigment, some cavitations or hydrogen attack. In a galvanic corrosion, for example, an electric potential can be set up between two different metals in a contact with a conducting fluid. This is a table number 10.1 માં આપણે જોયું. Okay, simply the part of these corrosive actions on a localized level ના basis પર જોયું આપણે. Okay, and the oxygen difficulty cells, stress activity surfaces, corrosive action can also be initiated by the galvanic action in the cavitation or hydrogen attack in a galvanic corrosion. For example, an electric potential can be set up between the two different metal. Is a contact with a conducting of fluid. Okay, all the metals. Okay, so for example, an electric potential can be set up between two phases or two different metals stay in a contact with the conducting fluid. The table match different metals and alloy. The magnesium alloys, zinc, aluminum alloys. Okay. Now the continue part. Combination of metals that are close as possible in the galvanic series should be selected, and the corrosive can be prevented by insulating the metals from each other. And the corrosion rate most of the metals is affected by pH. Metals such as aluminum and zinc dissolved rapidly in either acidic or basic solution, while the nobles and metals are not appearing and affected by the pH oxidizing agent of these powerful acidators. Okay, the most of important single properties associated with the corrosion activity. An example જો આપણે pH measurement range indicatedly છે 4 to 10 to the corrosion range of acid soluble, and the metals such as iron is controlled by the rate of that oxidizing agent and accelerated the corrosion of the one class metal and retard to the corrosions. Okay, another class is of metal by the formation of a protective oxide on the surfaces. Okay, this property is a chromium is responsible for the principle. હવે corrosion and resistance માં ફરક શું છે? Some characteristics of the stainless steel ના basis પર એના different types છે અલગ અલગ. The rate of corrosion and tends to the increases with rising temperature. In addition, for temperature has a secondary effect throughout the influence on the solubility of air oxygens in the principal oxidizer influencing the corrosion part. The rate of corrosion quite often will also increases part. If the increase is the velocity of the corrosive resistance to flow, okay, solution relative to the metals in the metallic in the surfaces. Simply, last 2 point, structural corrosion on the other hand included at least 3 different types of materials. Damages graphic corrosion as usually involves grey cast iron in which the metal is converted to the graphite mixed with iron corrosion product. Dezifications is the corrosion of the brass alloys containing zinc with the principal product of corrosion is metallic copper. In biological corrosion, the metallic activities of a microorganism can be either directly or indirectly cause the deteriorations of the metallic by the processes. And the biological activity માં જોઈએ તો some corrosive environment electrolyte concentration cells and metal surfaces नवी dispersion. Okay. Now most of the engineers are not today do not become expert in the details biological corrosions. Okay, so thank you so much.